Assalamu alaikum and good day, everyone. My name is Mohammad Saiful Bakhri bin Moshda Azmi. Together with my group members, Muhammad Hazik, Daniel bin Abdullah, and Muhammad Shahir Ayman bin Roslan. Today, we will be presenting a topic called number matrix, integration. In this presentation, we will explain what a number matrix is, the basic concept of matrices, and how integration can be applied to matrices. We will also show the step-by-step method to solve integration problems involving matrices. Before we move to the solving part, let's first understand what a number matrix is. A matrix is an arrangement of numbers or values in a rectangular form consisting of rows and columns. Matrices are used widely in mathematics to represent and solve problems, such as systems of equations, transformations, and even integrations. In this topic, we will learn how numbers inside a matrix can be operated mathematically, including by applying integration. By definition, a matrix is a rectangular array of numbers, symbols, or expressions, arranged in rows and columns. For example, A equals, begin matrix 2, 3, 4, 5, end matrix. This matrix has 2 rows and 2 columns. 2 columns, so it is called a 2 by 2 matrix. Each number in the matrix is called an element. For instance, the element in the second row and first column is written as a 2, 1. By definition, a matrix is a rectangular array of numbers, symbols, or expressions, arranged in rows and columns. For example, A equals, begin matrix 2, 3, 4, 5, end matrix. This matrix has 2 rows and 2 columns. 2 columns, so it is called a 2 by 2 matrix. Each number in the matrix is called an element. For instance, the element in the second row and first column is written as a 2, 1. There are several important types of matrices that we should know. 1-row matrix, a matrix with only 1 row. 2-column matrix, a matrix with only 1 column. 3-square matrix, a matrix that has the same number of rows and columns. 4. 0 matrix, a matrix where all elements are 0. Knowing these types helps us identify what kind of operations can be performed, including integration for each element. Each element in a matrix has a specific position, determined by its row and column. For example, the element of 12 means it is located in the first row and second column. In integration, we treat each element as an individual function. This means when we perform integration on a matrix, we integrate each element one by one according to its position. Before we perform integration, we need to understand the basic operations of matrices. Addition and subtraction can only be done when matrices have the same size. Multiplication involves rows and columns. Scalar multiplication. Each element is multiplied by a single number. Once we understand these operations, it becomes easier to see how integration works, because it follows a similar idea, applying the operation to each element individually. When performing integration on a matrix, the integration is done element by element. For example, if we have AX equals the matrix x squared 2x 3x 4, then the integral of ax dx equals the matrix x cubed over 3x squared x 3x 4, 1.5x squared, and 4x and b matrix. The steps are simple. 1. Take each element one by one. 2. Integrate it using normal integration rules. 3. Place the results back into the same matrix structure. The basic rules of integration in matrices are the same as ordinary integration. Integral x to the power of n dx equals x to the power of n plus 1 divided by n plus 1. Integral k dx equals kx. Integral f plus g dx equals integral f dx plus integral g dx. When applied to matrices, integral of fij of x dx equals integral of fij of x dx. This means we integrate each element separately without changing its position in the matrix. Now let's look at the first example. Given a of x equals the matrix 2x and x squared, x and 3x cubed. Steps to solve. 1. Write down the matrix clearly. 2. Identify the variable to be integrated, in this case x. 3. Integrate each element one by one. Integral 2 x dx equals x. Squared integral x squared dx equals x. Cubed over 3 integral x dx equals x squared over 2. Integral 3x cubed dx equals 3/4 x to the 4th power 4. Write the results back into matrix form. Integral a of x dx equals begin b a matrix x squared and x cubed over 3 and x squared over 2 and 3/4, x to the fourth power end, b matrix x to the power of 3, divided by 3x squared divided by 2, our frac 4 far nen b matrix. That's the final integrated matrix. To understand better, let's look at another example. B of x equals a matrix with 2 rows and 2 columns. The first row is x and 4x squared. The second row is 5 and 6x. Step-by-step solution. 1. Write down each element. Apply the appropriate integration rule. Integral x dx equals x squared over 2. Integral 4x squared dx equals 4x cubed over 3. Integral 5 dx equals 5x. Integral 6x dx equals 3x squared. Write the final answer back into matrix form. Integral b of x dx equals begin b a matrix end b matrix on frac snide 2 on d2 and end frac 4 chain 3 mart 5 6 and 3 styles 2 nend b matrix. Make sure all elements are integrated with respect to the same variable. To conclude, the topic number matrix, integration, combines 2 major concepts in mathematics: matrix structure and integration. The key steps to remember are: 1. Identify each element in the matrix. 2. Integrate each element one by one. 3. Write the results back into the same matrix structure. By understanding this method, we can solve various matrix-based integration problems easily and systematically. That's all for our presentation. I'm Saiful Bakri, together with my teammates Hazik Daniel and Shahir Ayman. Thank you for listening. Assalamu alaikum and thank you